Hi, this is Randal Schwartz, host of FLOSS Weekly. This week, Guillermo Amaral joins me. We're going to be talking about CoreOS. Looks like the perfect thing if you're deploying a lot of servers and has a lot of really cool features. You're not going to want to miss this, so stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for FLOSS Weekly is provided by CacheFly at CACHEFLY.com.
This is FLOSS Weekly with Randal Schwartz and Guillermo Amaral. Episode 314, recorded October 29th, 2014, CoreOS. It's time for FLOSS Weekly, the show about free, libre, open source software. I am your host, Randal Schwartz, Merlinist.ninja.com, bringing you each week, or as often as I can do it, getting pretty close to weekly again, the movers, the shakers, the big projects, the little projects you may be using every day and then being totally unaware of it, projects that are worth looking into, like maybe today's project will be one of those. We'll see, but let's go ahead and bring on my co-host for the show this week, Guillermo Amaral. Welcome back to the show.
Thank you. Thank you. It's nice to be back.
Yeah, I think we haven't done a show together in like almost 20 episodes, I think.
Yeah, it's been a while. I think you started not liking me, so, I stay away.
I enjoy everyone who is a co-host for this show because it takes so much load off of me, and I really appreciate that, especially when you guys team up together. And I know you did like 2 or 3 shows while I was gone, right?
Yeah. I think it's a couple with Aaron and maybe one with Dan, I think.
Okay, cool. Very cool. And where are you speaking to us from?
From my lab here in Tijuana, Mexico, as you can see in the back. Yeah.
The one that you're going to edit by putting in those light switches and things. Have you started doing that with the little things you were talking about with the devices?
Not yet, but I'm working on it.
Okay. I love it because
the downstairs floor is already actually really high tech now, so that's good. I got to work this higher room first, after I finish. So.
Very cool. And for people watching the video, they might recognize the green tree behind me. Make a careful note of that because this is the last time I'll be broadcasting from this office of ZipRecruiter. We're moving to a new location. It's about 7 blocks away that way. So I don't know if they have a green tree office over there, but I won't be in this green tree office anymore. Oh, well. Anyway, I'm in Santa Monica, and I will be here for today's show. Well, we have an interesting project today. The more I looked at it, the more I am fascinated by it. I'm not much of a Linux guy, so hopefully you know more about Linux than I do, I hope, and we can ask some good Linux questions that way. But it is about CoreOS or CoreOS, one of the two. I don't know how they pronounce it. We'll ask Brandon Phillips when we bring him on in a few minutes. But this apparently is a project that will be sort of like a core version of Linux that runs in like 40% less RAM, really great for distributed apps, really great for running in the cloud and having orchestrated coordination in the cloud. Looks like it's got tight Docker integration, which I'm pretty excited by, and a bunch of other things. Looks like I can run it from Vagrant, which always excites me because I'm on a Mac and I can't run Linux easily that way. What do you see about this so far, Guillermo?
Well, yeah, I the parts I know about CoreOS is that it's basically a really slimmed down Linux OS, right? That you can use to, do everything that, all those buzzworthy things that everybody likes, like cloud and integration and, having distributed systems. So I'm really actually interested in learning a little bit more about it because my Linux knowledge really only extends to desktop and, work systems, not really on the cloud stuff. So. Okay. It's going to be a learning experience for me anyway.
Good. Well, what's one of the great things is that I really try not to learn too much about the project because I want to be sort of a proxy for the people at home and ask the questions that I genuinely am curious about. And so this is another example of that. I only prepped for about a half hour for today on this project, so it should be interesting. Well, enough about us, enough about, this week in geography. Let's go ahead and bring on our guest. Brandon Phillips, welcome to the show.
Hey, thanks, guys.
Very cool. And where are you speaking to us from?
I am speaking to you from the Mission in San Francisco.
Ah, yes. I've been there many times, back when that was Silicon Valley in a big way, and used to go down there like probably every other week or so, but not so much anymore. A lot of my clients are all over the rest of the world now. So I gave sort of my impression of CoreOS, but can you back up a step and tell us what the 30,000-foot view and what problem this is trying to solve?
Sure. So what we're trying to solve with CoreOS is how do I run a lot of servers at scale? And how do I build something that makes a lot of sense for people who are needing a really consistent environment to run their web applications? Sort of how we pitch it to people who are less familiar with the technologies and the insight behind it is it's very similar to how a large organization like Google or Twitter or Facebook would build and operate their internal servers and operating systems.
And how did this project get started?
So I started my career at SUSE Linux, and I was working as a kernel developer there. And so there I was building a product that I thought, SUSE Linux Enterprise server that people just took off the shelf and they used it as is, and it would work well for their workloads. Then I worked on a large distributed system at Rackspace, and I found that what ends up happening is people will take a Linux distribution and they make it completely different. So they build custom packages, they just randomly install stuff in user local or /opt. And so what started out as a very nice and auditable system, because you have RPMs and apps and you can figure out what exists on the machine, turns into kind of a hodgepodge mess of custom-built stuff, system administrator installed things, and it's very hard to maintain over a long period of time, particularly when you're relying on this for your application to run. You install a custom version of Ruby because your application requires Ruby for its web service. So we tried to think about how do we pull apart the operating system on one end from where the application's running on the other.
Oh, that's good, because you just described pretty much the last 5 clients I've had, and probably even the ones before that, where it's like we don't know what the machine is. I mean, here at ZipRecruiter, they're doing basically, they build sort of a master version, and they're using AMIs in the cloud to manage that. But then we also have this little, our little vagrant boxes that sort of look similar, but we know it's not exactly the same thing as what we're running in the cloud. Would something like CoreOS help us solve that?
Right. So CoreOS is, every machine on CoreOS has an identical bit-for-bit version of the operating system. And actually what ends up happening is the entire CoreOS piece of the install is completely read-only. And we actually set bits on the file system to ensure that the kernel can't even mount that as a read-write file system. And so it's something that the user can't even modify. The entire /user is read-only and not something the users are expected to modify at all.
Okay, and then I was skimming the documentation earlier. Something about Docker and how that relates to this. Does that help you out? Yeah.
So when we started CoreOS, we thought about, well, how do you naturally separate the operating system from the application? And we wrote down, if you look back on the Wayback Machine for CoreOS.com, it's minimal OS for running Linux containers. And so Linux containers have been a design requirement of what we were trying to solve with CoreOS, because it allows you to say the application lives here and the operating system lives here, because everything in a Linux container is self-contained, thus the name. And so and then we kind of fell into, as we were getting CoreOS first release out, we talked to Solomon and the Docker team, and what they were doing was really relevant to what we were doing. And so the first couple of releases of CoreOS had the very first couple of releases of Docker inside of it. And we've kind of been, we've been using Docker, and our users have been using Docker since that first release.
And so what's the current status of CoreOS? Is this deployable now or still a preliminary project? How far along the development cycle is it?
We're pretty far along. So you can take CoreOS, and we have worked really hard with all the cloud providers. So you can run it on Rackspace, Amazon, DigitalOcean, Microsoft's Azure, a lot of OpenStack providers all over the globe who run smaller operations for individual countries or individual geopolitical areas. And so we have distribution that's pretty wide, and we also allow you to run it on bare metal with a Pixie boot or Vagrant or KVM. So pretty much anywhere that you'd expect to run Linux, you can run CoreOS.
And one of the things I saw was the reduction in memory that the basic footprint has. I may not understand the answer, but what did you do to Linux to make it so it has a smaller footprint?
I mean, essentially, we just run less stuff. So what we do is we try to socket activate. Socket activation is a mechanism whereby daemons don't start until you talk to them for the first time. And so we try to socket activate as many daemons as we can. So, for example, we added the ability to Docker for it to socket activate. So it's not until you actually talk to Docker that the Docker process starts running. And so if you continue down this line and you just run fewer things, you're going to have less memory consumption.
So I have a question. I noticed in your website that you guys have a lot of different companies, that are already using CoreOS. I think Akamai is using them, for example. Are they helping you guys develop CoreOS on any way, or do they have any developers assigned to you guys to help?
Yeah, so it's kind of hard. We have a large open source community, so I don't know. Particularly when people jump in IRC, it's hard to tell if they're just open source contributors or customers. But we do have a lot of people who use components of CoreOS, not just the operating system. So there's people like the Google Kubernetes project and Cloud Foundry's Diego project who use components like the etcd component. And then there's also people who help out by filing bugs, fixing packages, that sort of thing. So it is kind of the long tail of contributions that you'd expect in an open source project. And then we also have a ton of people who file bugs and help us on a regular basis.
Are you guys working on something specific with any of those companies, like Google, for example?
So when we're working with Google, as a specific example, Google open source a project called Kubernetes, and the Kubernetes project is ran as a regular open source project, and we some of the CoreOS guys are contributors. Also, internally in Kubernetes, they use etcd, which is our distributed consensus key value store. So there's collaboration there in that they're using and filing bugs and asking for features against that piece of CoreOS, which is the core distributed systems piece of CoreOS.
Is there anything stopping, for example, me as a developer on Linux? Is there anything stopping me from using CoreOS as a something for my Linux desktop or my laptop? For example, I mostly use BIM. I'm sorry, Randal. I mostly use BIM, so I wouldn't really need the GUI, the GUI, to be able to work on. So,
yeah. So CoreOS, we're very much focused on only servers. Ideally, over time, we would have fewer and fewer binaries that are sitting on the operating system that you actually would SSH into the box and poke around on the system. But we don't compile in most graphics drivers. And so we try to slim down the kernel as much as possible to just reduce the surface area of things that we have to support, because we are focused very much on servers.
Is there, well, maybe we can probably touch on this a little bit. Let's say I install CoreOS on a few of my machines here and I want to get something distributed, working on them. Is there any IPC in place that I'll be able to use, to be able to talk between machines, or how would the distributed system work?
Sure. So the kind of design principle behind etcd and CoreOS is that you want to define how the operating system or how the environment is set up. You don't want to tell individual machines what to do. So you'll see this a lot in sort of the design philosophies at Google, and particularly the Kubernetes project. You tell the computer, I want you to be running 3 of these things, and I want them spread out on separate machines. And so in CoreOS, we have a very simple scheduler called Fleet. And so you can tell via the command line or via an API, I want 3 of these processes running in my distributed system, and I want to ensure that they aren't all on the same failure domain, and in this case, on the exact same servers. And so you define what you would like to happen. And that way, the system itself has the flexibility of saying, oh, well, machine B that was running this process died and went away, but machine E came up, so I'll reschedule the work that was running on B over to E. And so that's sort of the internal mechanism, is you tell the system what you want, and the system figures out how to get it there.
Oh, nice. So I guess with the reduced stack of applications you guys are already handling, does that help with let's say with security in any way? Or are you guys have a special security package you add on or something?
So one of the general, the ethos of the project is that we want to secure the internet. And one way that we do that is that we have a mechanism whereby the system can actually self-update. So if you're familiar with like your Android phone or if you have a Chromebook, these systems, they download an update and then they prompt the user, hey, you have an update and it's available, and you just need to restart your system in order to apply that update. And so in CoreOS, we have a very similar mechanism. We have a partition and a B partition. And while you're running on, say, the A partition of CoreOS, we'll update B partition in the background. And so this means that when there's a security vulnerability in the kernel or in any of the components, internal, etcd, Docker, et cetera, to the operating system, we're able to make an update publicly available, and then machines are able to quickly download those updates and apply them and be able to reboot into that new version of the operating system. And since we've kind of separated out the operating system from the application, we can do this on a more regular basis because we haven't made the API contracts so gigantic as a lot of these operating systems do today, where we're like, well, we provide Python and Ruby, and you rely on us for your HTTP web server, et cetera. Since we're just the kernel and these few components, we are able to say the surface area is a lot smaller, so it's okay if we have this more automated update system on a regular basis.
So, okay, so you guys are, you mentioned making some kernel changes, right? So are you guys upstreaming in these kernel changes, or do you just keep them to yourself, or how does that work?
Yeah, we have no kernel changes at all. So the only things that we customize in the kernel is we strip out things that aren't necessary for a server. So we don't, say, ship all the graphics drivers, for example. So actually, one of the things that I'm very proud of on CoreOS is that we ship the kernel.org kernels, the --stable kernels. And actually, Greg Kohartman, one of the Linux kernel stable maintainers, helps us maintain our kernel, and he works on the project in that capacity.
Oh, that's great. You never see big projects like this using vanilla kernels, rarely anyway. At least coming from a Gentoo side view, you always get a few patches in there. Even if you just keep them for your own distro, right? You just put a few patches in there, to make it a little bit fit more your ecosystem. But I like it. If you guys are using vanilla, that'll make it a lot easier to upgrade and downgrade to different kernel versions, right?
Yeah, absolutely. And it's nice because any bug report that we find, we can directly report to the kernel maintainers. And since we have this automatic update mechanism, when we find things, it's usually a fairly fresh kernel. It's not like, oh, some user found on 3.5.11 that this thing broke. And the very first thing a kernel maintainer is going to say is, well, you should try 3.16 and see if it still reproduces. So the fact that we have fairly fresh kernels actually it helps the kernel community out too.
I'm really liking this idea, this notion that you've got, that you're able to swap out the kernel because of that small contract between that and the next layer up. So is this something that I could sort of set as fire and forget, so I could have all of my my EC2 EMIs and whatever the cloud service I've got just sort of automatically do an update by watching some sort of RSS feed or something?
Yeah, so by default, and it's totally configurable, by default, CoreOS instances will automatically download and do a signature validation on the download, the latest version of CoreOS based on the channel that you're on. So we have an alpha, beta, and stable channel. And so your machines will just download that and apply it and then reboot. Optionally, they can also take a lock. So if you have etcd set up for your CoreOS machines, they'll take a mutex so that not all the machines in your cluster reboot at the same time. So one machine will take the mutex, it'll reboot, and then it'll release the mutex, and then the next machine will take the mutex, et cetera, and go through the entire update process for whatever machines are in that group that you have.
You mentioned etcd a couple times, etcd, I guess it is. Can you describe more about what that is and the functions it's offering?
Sure. So one of the core tenets is that you want to build a system that is resilient to failures of individual machines. But you need configuration data. You need to say, well, I want these machines doing X. So you need to build a system whereby this data, this really important configuration data, is replicated across a handful of machines. And those machines, upgrading or having hardware failures or being destroyed by your cloud provider, this configuration data will survive those sorts of faults. And so etcd is the holder of that important data. And this is very similar and very much inspired by a white paper from Google from a long time ago called Google Chubby. And we essentially provide this key value store and some additional mechanisms to be able to do these safe cross-machine mutexes, because generally mutexes are on a single machine, and once you add lots of machines, you have this problem of, well, how do I know I've acquired the lock? And so etcd gives you the capability to acquire these distributed mutexes and ensure that this important configuration data is replicated across the cluster.
And so let's get a little bit more geeky here for a second. So would you consider etcd to be sort of the core contribution that makes CoreOS possible?
Yeah, I think that it is it's this core building block of a distributed system, and we haven't really had a good ecosystem around these consensus data stores in the open source community. And so I think that absolutely etcd has been one of the surprisingly very popular components of CoreOS. When we built it out of necessity, and we didn't know people would show up. And now we have, the Google Kubernetes project uses it as their consensus data store. We have the guys at Cloud Foundry on the Diego project using it as a data store for their orchestration system. And so it's not just CoreOS using this and depending on the project. It's just such a central component and it's a very difficult thing to build properly. So I am pretty proud of that project and that piece of tech that we built.
Is there an API exposed at the application level for this? Could I use it for user applications to have some replicated data that needs to be consistent?
Yeah, absolutely. So one of the things that we did with etcd that's a little different than existing consensus stores was we use HTTP and JSON. So we've actually had people who are writing, distributed locks in Bash on a cron job. I wouldn't recommend it in a production system, but I mean, it's possible because you can use curl, you can use sed and grep and kind of like hack together a thing. But also, every web or every application, every language allows you to use HTTP and JSON. So like Python and Java and all these things naturally are able to deal with interacting with this API without fancy bindings.
Now, how different is the layer towards the application setups? Like, does Ruby and Perl and Python see this as just a normal Linux distribution, or have you had to customize that as well?
So it depends on the container. So in the Docker community, you see a lot of these sort of language-specific containers. So the idea there is that you build a container that just has your application code, and then the container that you built it off of contains that exact version of Ruby that your application is expecting. And then there's also other ways of building containers. So in a lot of cases, it's really easy, and what a lot of people end up doing is they'll take a base, say, Debian image, and then they'll apt-get install the dependencies of their application, and then add the application at the end. So to the application, it looks like they're running in a Debian user space. They're not really even aware that they're running on top of CoreOS. But it's up to the application, and the application brings along the pieces of the API that they need. We just provide the POSIX and Linux syscall layer, essentially. Okay,
and development on this. What How many people are contributing to etcd and the other pieces of this? And what do you do for testing?
So that's a good question. I think in the last alpha release of etcd, we had around 50 contributors. And then the CoreOS projects as a whole, so the operating system, fleet, our scheduler, many more contributors outside of that. For building the actual operating system, we have an SDK that you can download and instructions. So the entire build system is completely open source, and you can just start from a Git pull, and then it walks you through all the way building a running KVM image in about probably 5 to 10 commands to get you from that base Git pull all the way through to a running image. I forget the last part of your question though.
Oh, testing. How do you test something like this?
Oh, sure. So what we end up doing is we have a master channel. So for each of the platforms that CoreOS runs on, we spin up a set of machines. So we spin up a set of machines on hardware. We spin up a set of machines on Amazon, DigitalOcean, et cetera. And every time we do a build, we push out to master, and we ensure that those machines are actually still operating correctly. And so we have pretty graphs and stuff around whether that's actually happening as expected.
And your test suite for that, is that something that's available too? Like I could run it on just a random Linux installation just to make sure everything's working?
Yeah, so it's a little Go program called Core Test, which just runs through and makes sure that the central components of CoreOS are still like a basic, burn down test or something to ensure that they're operating correctly. Because we do rely on individual unit tests in each of the components to ensure those components are fully correct internally. So this is just ensuring that the operating system built properly and that the things that we are expecting to be running when the system comes up are running.
Cool. And you mentioned Go just now. What are the other technologies that you're also using for this?
That's a good question. We use Go really heavily. So we use Go for Fleet and etcd and CoreOS Cloud Config, which is the thing that takes this YAML file that a lot of cloud providers allow you to define and transforms it into the initial configuration of the machine. We rely heavily on Docker, obviously, and systemd is our init system. And we use a number of the components there. And we started one of the new pieces of systemd called networkd, which is a nice, consistent way of defining the three major pieces of a network stack. And so we rely on very few projects, but we rely on them very heavily. So, systemd and Docker, the Linux kernel, etcd, Fleet, those sorts of things.
And since you're using Go extensively, what's your 3 biggest complaints about Go so far?
So having to vendor all the dependencies is a little unfortunate, but it also goes towards, you get some nice benefits in that you get these nice statically compiled binaries that, end up shawing to the exact same hash every time if you use the same compiler. So there's very nice properties. It's a little annoying as a developer, but I think that sort of the advantages outweigh the disadvantages. I'll spare everyone from the usual joke about generics, but overall, I've been really happy with the language, and I know the team has been super happy and productive with it too.
Was this your choice at the beginning?
It was something that we kind of latched on too early. We needed to build etcd, and we saw that a lot of really interesting distributed systems were being built on etcd or on Go, and so we picked it up, and it's been a pretty good fit for everything that we're doing. When you look at the entire spectrum of languages, there's very few languages that allow you to do the sort of concurrency that Go does naturally, and does it in a way that you can actually, debug it, and a mere mortal can understand what's going on where.
Well, you didn't just do everything in Node.js like everybody else does?
So I spent 3 years working on a Node.js system at Rackspace.
So you know why you didn't choose Node.js. Okay, good. I keep saying, well, the biggest problem with Node.js is it's JS. I mean, that's always been the issue for me with that. And now that we have Dart, we don't have to worry so much about that. But that's a whole nother conversation. So you keep saying we. I'm wondering about the funding model for this. How is this getting paid for?
Sure. So CoreOS Incorporated is a venture-backed company. We have full-time employees and engineers who work on this stuff, and we build all the major components as open source software. And really, it's something that I'm really excited to do. When I was at university, at the Oregon State University Open Source Lab, I said, hey, I want to be me and my co-founder were like, we want to be open source developers, and to be able to contribute back to projects that are gaining popularity like we have at CoreOS is really satisfying, and I'm glad we're able to do it.
Well, okay, given this is VC backed, what's the long play for them?
Yeah, so we have a number of commercial products. If somebody's interested in them, you can find them at coreos.com. We have hosted software as a service things that make managing CoreOS machines easier. And we also have a Docker registry that people can use software as a service or run behind the firewall.
Okay, and what's the licensing on this?
The CoreOS, the operating system, and all the updates and everything are freely available. You can compile them yourself. All that stuff's completely open, just like any other Linux distribution. You can download the updates for free. We host and mirror all the updates and the images for free. And it's something that people can absolutely go off and fork the SDK and build their own copy of CoreOS.
And you keep saying like Linux, they must mean GPL v3.
Well, yeah, I mean, it depends. Like Linux, what is the license of Linux is really complicated because there's components that are Apache and MIT and GPL v2, and yeah. So,
what if I wanted to get started on this? I see that you have a Vagrant thing, so I could play with it in Vagrant, and that's what would be my interaction with it to say build a standard LAMP stack and start playing with that? Do I need to spend a lot of time writing configuration files to say, here's what I want in my stack? Or am I just downloading a Docker container and installing that LAMP stack Docker container? How do I get from ground zero to actually being able to use this and play with it?
Yeah, so you can start essentially by just starting 3 CoreOS machines, and you can just use the raw components right there. So you can write a systemd unit file that starts up a Docker container that's running a hello world PHP app of some sort, and it just kind of works that way. You can say run it on my 3 Vagrant hosts that I have running on my laptop and hit each of them and start there. And then you can get a little fancier with it. You can run things. We have blog posts explaining how to run the Google Kubernetes project, where that gives you more of a feel for a platform where your application is running alongside other things and is able to interact with service discovery and that sort of thing. And then we have other projects that are interesting, like the Deis project, which is built on top of CoreOS and provides a full feel of like a Heroku, where you can go git push your application and it builds it and then runs it behind a load balancer on your VM.
So I could set up some sort of configuration file that says that I want this one of my virtual boxes to be the web server, and this other virtual box to be sort of the database server, and maybe the third one to be sort of an Elasticsearch box. Is that something I would just publish once and it would set everything up for me, or do I then need to get all the right pieces for that?
Yeah, so generally you write a service file that says run this container. So run this MySQL container, or run this web server container. And then you tell Fleet, which is our basic scheduler, run this somewhere in the cluster. And then that part is handled. It gets a little tricky around things like MySQL, because if that machine goes away, you need some way of handling the replication. And that sort of thing. There are databases that are better at doing replication. I think that's a huge area that needs addressing with all this stuff. Is we have large companies that have these really, really awesome replicated data stores. In the open source sphere, we don't have a lot of really great options today. There's some products that are really great, but the open source community doesn't really have a really solid handful of tools there.
So let's say if I want to, Tommy, I wanted to jump in here.
Sure.
If I want to set up this on let's say another Linux machine, right, and I want to start playing around with this, I want to set up one to be MySQL server, as Randall said. Would I need to be able to, well, rather, would that single machine be able to set everything up on the other two? If I want to change, for example, if one is a web server and I want to make it a MySQL server also later on, would it be able to do that on its own, or would I need to shut that one down and start it back up again?
Oh, yeah, you can reconfigure the CoreOS machine and turn on and off containers. And we even have a cute little command line client for Fleet where it will transparently SSH into the machines and be able to hit the API from your host Linux workstation. So you can absolutely do things like, oh, I want to try out this MySQL container that didn't work out so well. I'll destroy it and I'll start up another thing. And that's since they're in containers, they're completely isolated from each other. So if you tried out MySQL 4 and it wasn't so great for you and you shut it down and you started up MySQL 5, that's perfectly fine. You can even run them next to each other on the same host.
Oh, okay. Okay, so containers work kind of like BSD jails then?
Yeah, exactly. Like this is technology that we as a technical community have built before. It's just that we're getting the tools and building the user experience that makes it possible for people to use them well on Linux.
Well, to be able to use an API from a host machine to control all that is a game changer. At least from what I remember, doing a lot of BSD jails and stuff before. Yeah, I really like that idea. So let's say I have a base system, right? And I want to set up let's say, build farm for an application I'm working on. That I would need to make my own container that has everything set up in there. And is there a way for me to push up all my code to all the different machines, or would I need to use something like this is here? Go on.
Yeah. So the basic process for containers, you define the build process, and that is defined in Docker as a Docker file. So this says like run this command and then copy this binary to this location, and then after that's done, you upload it to a registry. There is an open source registry. You can also use a hosted registry. So we provide a hosted registry at quay.io, and so you upload the container, that built asset, you upload that to wherever it is. So we'll say it's uploaded to quay.io. And you then on each of the machines, you say, I would like you to run this URL. And the URL is, say, quay.io /floss weekly /container. And so that then downloads that container and starts the process that was defined to run for that container on the machine. So it kind of solves this installation problem by saying you run essentially a URL, you run a string, and whether it's on the machine or not, it'll download it and then start it.
So you guys being a for-profit company, I guess, in the end, right? Would you guys have everything set up for somebody who just wants to launch a few VMs and be able to configure them? That I don't have the actual hardware, let's say, and I want to set up my own build farm.
Oh yeah, so so if you use quay.io, you can actually set it up to say point at this GitHub repo, and every time the GitHub repo changes, rebuild my container. So you can do that level of automation. We don't actually host machines though, so if you want to try out CoreOS and use it as a build farm, so you don't want to use a hosted service to build your code. You want to run it on your own machines. We have really fast guides so that you can say start up a AWS or a Rackspace VM, and on that VM you can check out the code and then run the Docker build, and then upload it to say a private registry too.
Oh, nice. So you can use something like AWS then, something already out there, well known, right?
Yeah, absolutely.
Oh, that's good. Okay, so what's the plan? Let's say from here in 2 more years. Do you guys have any special new feature that's coming out? Maybe something that's not under hush 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 license right now.
So I mean, 2 years we run the world servers, but I think that essentially what we'd like to do is continue to make the things that we built really solid. At the end of the day, as somebody who has and continues to wear a pager, I'd like it to be the fact that if you want to build a system in which you are resilient to failure, and you're not getting pages in the middle of the night, you get a good solid night's sleep as an administrator or a software engineer, you build a system on CoreOS. And so just continuing to make the things that we've already built really solid and continue to work on the user experience so that it's really clear what technologies you choose and how you go about building a system that is resilient in this way.
Is there anything in this space that you're sort of competing with?
So when we started CoreOS, there's not really been anything that's built the components that we have and put them together in the way that we have. Obviously, there are plenty of Linux distros already, but building it in this way with this focus on servers only and a focus on distributed systems as a first-class citizen, there really hasn't been.
And we actually had a question from the chat room for Sandman, came from Sandman anyway. Is this container pure Docker that could run on MS Azure next year?
So CoreOS is available on Azure as a virtual machine. Recently, Docker announced that Windows as an operating system would start to support containers, but I don't know what that looks like over time, because obviously a Linux binary, a Linux AMD 64 binary isn't going to run on a Windows server. So there's going to be a recompilation, and the packages will be separate binary packages. So it depends on what you're looking for, but you can run CoreOS on Azure.
And I want to talk a little bit more about the roadmap situation. So you've obviously you're looking into the future and you're picking specific features to add to this. How much of that is decided by the people who are actually paid by the CoreOS company, and how much of that is decided by people outside the company?
We do take all of our user feedback, and it's definitely something that we heavily consider. And a lot of the really good ideas in CoreOS have come from people who are on the ground using the thing. Mm-hmm. So there has been a really good contribution and feedback system there. We do have a lot of opinions on how this thing is built, and so there's certain things that we don't really feel we should compromise on. So like, we aren't going to install Emacs, sadly, on CoreOS.
No.
Simply because that means that we've added an API, and it's an API that people may come to depend on, and it's not necessarily something the operating system should be involved in. Having a full eLisp interpreter that people may start writing web applications against.
Well, actually, that's not really much of a downside of Emacs. I don't see that Emacs was actually be any more dangerous than having, say, Vim installed, because the non-X11 Emacs doesn't have a standalone eLisp. The eLisp is so inherent in it, it's not going to be much of a problem.
Yeah, it's mostly about ensuring that we keep the CoreOS piece as small as possible.
True.
I mean, even today, there's things that I want to take out of CoreOS, but it's just we don't have all the pieces in there to make it really safe to take them out. So over time, I mean, it'd be great if, right now our images are slightly under 100 megs for a full root FS of CoreOS, and over time, I want that to continue to come down.
Oh yeah, of course I could always install Emacs in a container sitting on top of it, so I really don't need it in the core.
Absolutely. So we provide a tool called Toolbox, and Toolbox on CoreOS essentially helps you download a root file system, and you're able to install things like, say, TCP dump. And the nice thing about that is that after the system administrator is done, using TCP dump or Emacs or whatever they need to do on the box, they can just blow away the toolbox directory, and they've essentially like uninstalled everything that they installed to debug the machine.
And I've got a question whispered in my ear here. Is there a chance that CoreOS is looking for more developers?
Absolutely. So we have really clear contributing guides on all of our open source projects. We really appreciate when people come by and help fix bug reports. Just last week, we had somebody come by and fix a bug in etcd that was really tricky and provided test cases. He was a PhD student in Toronto. And these sorts of things, particularly the drive-by, here's a bug fix with test cases, are super valuable. But even that said, a well-written bug report is super helpful, particularly if it's things that we can take off to the kernel team or fix up in any of the open source projects that we rely on. We really appreciate that too.
I was thinking, I think the question was more phrased like, are you, as CoreOS, the company, hiring people?
Oh, yeah, absolutely. So we regularly make job postings. If you've missed them, feel free to email me or partners@coreos.com.
And one more circle back to that etcd thing. So you have this part of it that I'm really fascinated by this consistent data key value store. Is that possible to abstract out as a separate project so I could use that without having the rest of the etcd framework?
Yeah. So the core like fundamental piece of etcd is an algorithm that came out of Stanford called Raft, and we provide a Raft library that other projects use. So if you don't want to use a key value store exposed over HTTP and you want to say another person took a Raft library and they built a replicated SQLite server. So if you want to do something interesting with this core distributed systems component, Raft, we provide a really simple stripped down Raft library in Go that a number of projects have started to adopt. And it's been a piece that is very tricky to implement because that piece requires a lot of testing, and if you get it wrong, you've essentially broken the only core promise of the product, which is that it's distributed and consistent. So
yep, that's impressive. So is that Raft, R-A-F-T, Raft?
Raft, yeah, like a little boat.
Like a little boat. Okay, cool. Just trying to. Sometimes the accents are a little tough to pick up. I know your American accent, but it's still, I'm from Oregon. Your accent's not from Oregon, so I have to always make sure I'm listening to the right thing. Where are you from originally?
I'm actually from Oregon, so I guess
I have been out of Oregon far too long. I'll be there again this weekend, but that doesn't mean I remember my own accent. This is how embarrassing was that? Okay, great. No, but you were from Corvallis, though, right? So
yeah.
Slightly different accent, slightly different from Portland. Just a teeny bit. And Skype doesn't help either. Okay, we're almost out of time. Is there any question we didn't ask that you want to make sure our audience is aware of with regard to this?
Ooh, that's a good one.
Mm-hmm.
I guess the thing that would be interesting is where people can sort of get involved and hear more about this stuff. So we have a website at coreos.com/community, and we have regular meetups, and we have mailing lists and IRC channels. Which is really helpful for people who want to get involved and hit the usual snags getting started with all this stuff. And that's a great place to get started.
So people can come in and start figuring out how they can get involved and contribute and at least get started with it, at least start playing with it.
Yep, absolutely.
Very cool. And my 2 required questions, which again, I'll get email for if I don't ask, your favorite scripting language, but I think I may actually know what this is. Go ahead.
Go.
That's what I thought. Yeah, okay, that's fair. Absolutely fair. Well, some would say it's not really a scripting language because it's compiled, but then again, Perl's compiled, just can't see it. Anyway,
Go
and sorry.
The Go command line has this thing called Go Run, and you can run an individual .go file, and Go compiles so fast it feels scripting.
Yeah. Okay, that's cool then. And your favorite text editor?
Vim.
I didn't win on either one of these. And when I wasn't here, some guy said Emacs. That's not fair. Anyway, well, whatever. It's all good. Well, it's been a wonder. It's been fun chatting with you. And you know, I can see, like, even here at ZipRecruiter, I think we've been looking for a solution that's similar to this, looking at Docker already. But if we can also base it on CoreOS, it sounds like we solve a bunch of other problems that we were also looking at. So I will certainly be recommending this to my primary client right now. It's been wonderful talking with you about this, and I think you've probably piqued the interest for a number of other of our listeners as well. So thank you for coming on the show.
Absolutely. Thanks for hosting me, guys.
Very good. That was Brandon Phillips, who is talking to us about CoreOS. What do you think, Guillermo? Guillermo, sorry.
That's fine. That's okay. Well, I honestly, I really like the project, especially this toolbox feature he mentioned. But before, I used to have a farm of web servers, and it was always a pain. They were Gentoo web servers, but it was always a pain to install a tool and then having to clean that up just in case somebody hacked into it. Having this toolbox feature is really, really nice. I'm actually interested in playing around with this, at least for a build server.
Yeah, and I'm looking at it too. Like I just said in the closing there, I think this is the kind of thing that my current primary client is going to be interested in, because we've been looking. I mean, right now there's this complex maze of scripts that are set up to, bring down the load balancer and bring up the next AWS box and update the Perl on each of the boxes and update the code base in each of the boxes and things like that. So it's a real mess, because that same thing has to be applied also then to my virtual box where I do my development in, and yet I'm not running the exact same OS that they're running in the cloud, so there might be differences there, and I have to keep regenerating the same bits, which is silly. I mean, the script actually goes to the source files on the CPAN and compiles them, and it's like, why not just do this once and have like identical images for everybody? So I'm really liking the looks of this. So I'll definitely be walking right over there in about 20 minutes when we're done with the show and talking to the chief technology guys here that are interested in trying to solve this problem. Anything else, Guillermo, before we go on to the last part of the show?
Well, I feel you guys really had an opportunity to do an Abbott and Costello who's on first type skit right there with the what's your favorite scripting language? And he goes, go. Then you go, I did. What's your favorite scripting language?
I missed out on it. I missed it.
Yeah, you did. You did.
It's horrible.
That would have been great television, internet television.
That not enough caffeine yet today. That's part of the problem.
Yes,
all right. Well, that's good.
You're telling me.
Very good. Very good. Well, let's talk about who's coming up. We've got coming up next week, we've got RethinkDB, which is a distributed database for JSON documents. They seem to be solving a number of issues regarding the sort of key value stores or complex tree stores that other people have been working on. There's been a lot of people in this space, so we'll see what RethinkDB does differently and see what their contribution is for that. Immediately following that, for now, the third reschedule is Docker, which is we talked a bunch about in today's show. So we've got sort of a preview of what Docker is going to be about, but we're going to talk to the dude himself, who's going to be, unfortunately, the name's not in front of me. It's on my other spreadsheet, sorry. But we'll have him on. Hopefully, I'm placing only 90% bet that we're going to actually get this show done there. A couple of weeks of open shows right now. We're scheduling all those over this weekend, probably. And then we'll bring in Open SMTPD, which is OpenBSD's secure mail server. So that'll be interesting as well. Again, Q4 is still open. We've got a few more weeks to fill. Still sending out the emails this week and next. Boy, I tell you, that's 90% of what I do for this for FLOSS Weekly is get these guests scheduled. So it's been a lot of fun. But if you do have a project that I'm not currently talking to, which you can find out by going to the spreadsheet linked from twit.tv/FLOSS, which is the home page for the show, you can have the project later email me, merlin@stonehenge.com, and I will be glad to put them in the giant spreadsheet and send them random emails from time to time saying, hey, we got some slots open. When do you want to be on the show? Very cool. You can follow me at Merlin, MERLYN, and I'm on Google Plus as Randal L. Schwartz. You can also follow FLOSS Weekly on Google Plus to get announcements of new shows coming up. Usually there's a 1-hour announcement before the day of taping. And then there's also usually, as I book new guests, I put out announcements for them as well. One thing I forgot to mention, because I didn't research it very well, on episode 311, which is about 3 episodes ago, I was talking about the D programming language. What I just found out last night is that there is a Schwartzian transform built into the language called Schwartz sort. So I am immortalized in the D language, and I didn't know it while I was interviewing the guy. That is so sad. My research apparently does not work all the time. Somebody pointed at the Schwartzian transform page on Wikipedia the other day, and I immediately went and looked, and I went, oh, it's in the D language. Oh, and it's called Schwartz sword. How much better can you get than being immortalized that way? The next couple weeks, I will be in the Buffalo area. If you're there, please contact me. There's various ways to get a hold of me. I'm sure you could figure one of those out at least. We do actually have a meetup already scheduled. It'll be November 6th in the evening at the Pearl Street Bar, which is appropriate given that most of them will probably be Pearl users, spelled differently, of course. On November 29th, I'll be in London also for a meetup, working out the details for that now. It depends on where I'm actually staying. I think I'm staying near the airport, though, so it might be kind of awkward. But hey, they got Uber. I'll just ride around an Uber for that. And I will be with all the crew, as many crew as we can get there, at the Brick House for the New Year's Eve party. So I'm going to try to see how much of that I can stay awake for. I'll probably start showing up around 6 or 7 in the morning. It would normally have been a Floss Weekly taping at 8:30, but we won't be taping any actual shows. It'll just be lots of discussion with other people, so it'll be a lot of fun. I hear Aaron's going to be there as well, so we'll have a good time there. I think that's all the plugging I'm going to do for now. Guillermo, your plugging would be?
I guess my Twitter account, which is at GAMARAL. That's Gamaral. You can also check me out on About Me/Gamaral. And you can look me up on Google+. It's Guillermo.Amaral. So just search for me. I'll pop up somewhere.
Very cool, very cool. And thank you once again for being the co-host on this show and co-hosting those other shows that we also did.
Yeah, man, no problem. Anytime.
Very cool, very cool. Well, I hear the music coming up, so you know what that means. We'll see you all again next week on Floss Weekly.